So this is a very big picture of project 2. Owing to a request of many students, so we thought that we'll give you a big picture of project 1, how to go about it if you're having any problems. Okay, so the project 2, there are three major steps that you have got to do. So one thing is, so you will consider the same points from two different cameras, and then you have to project them from 3D to 2D. So you have to superimpose them on the image and then use triangulation for the reconstruction. So in a very big picture, these are the only three things that you need to do. So the first and foremost, I don't have to explain much. You just have to initialize the video reader. So just take the newly updated .mp4 file, put into a variable, then call the video reader function, which will create a structure which will contain a pointer to the actual video file. And then you can read frames from using that video reader, using that variable. That will be the first step. The second step is you have to load all your mocap joints. This mat file will contain all the joints information that is obtained from different cameras. So fairly straightforward. And here starts the actual project. So the first thing that you need is you have to find out what are the good frames. So when we say good frames, it means that the confidence value is 1. So what you need to do is you have to loop through all the frames. When you loop through all the frames, you have to check if the confidence is 1. And when the confidence is 1, you have to make note of that particular frame and also the mocap values for that particular frame. So what I suggest to do is I suggest you to use structures. So for example, if you're, let's say I have frame as my structure. Okay, so frame of 1 dot f is equal to frame number. You can use this one. So for example, first let me just type what frame number is. Frame number equal to 1 and okay, and then frame of 1 comma joins is equal to whatever values you want. I'm just going to say 1 2 3 4. Okay, so this is just a clue for you on how to do it. So if you do just this much, and if you go here, you can see that frame is a structure and it has f1 and f2. Let's say I want to do frame number is equal to some 300, and then let me just do this. I'm just giving different numbers here. Okay, so now you see that frame has two structures. So the first is so the first frame has 1 2 3 4, and the second field has frame number 300. So you have to make sure that your f contains the frame number. So it means that from 1 through 300 there are no good frames, only first and 300 frames are good. This is just an example on how you can uh, optimize your coding. Okay, so having this kind of structures will help you a lot. So now that you have created a structure of frames, okay, then you can go ahead with loading the calibration information that has been already provided to you. So using this uh, calibration information, all you have to need to do is, so first calculate the extrinsic properties which you will get from rotation and translation, and then calculate the intrinsic properties. You will get that from affine and projection, and also you have to calculate the location of the camera. uh, all these are there in the lecture. You just have to go through it and find out. Okay, so here I'm giving a very big picture idea of how to go about this project. I'm not going into details because that would be giving away the project itself. It's very simple. You just have to go through the lectures and directly put them into MATLAB version. That's it. So you can write a function of this sort, calculate M matrix, and the most important variable here would be the VUE, which contains the calibration information. And if you need any other variable as input to this particular function, you can use. So probably I would choose only this one and not anything else. But if you need any, because if let's say if your coding style is different and if you're trying to, if you need any other information, then you can use whatever you want. But I'm pretty sure that you don't need anything for this particular function. Okay, so all you need to do is you have to find out the M matrix and the location of the camera. Next, what comes next is projection of 3D to 2D coordinates. And I think this you can do within just 4 to 5 lines of code. All you need to do is you must have M matrix. This is the most important. Okay, also the another important is the points that you get, the joints. Okay, let me write it properly. Joints from, okay, so you will need the joints from the frame. And where will you get this from? You're going to get that from this particular frame structure. So if you send this, might as well write it as frame. Okay, so if you send this frame structure, so you will know the information of all the frames and the joints that are there in that frame, and whether that frame has a confidence value of 1 or not. Okay, so for example, if you want to send a particular frame, for example, if you're only working on one particular frame, probably you can just add frame number and then access that frame number from this one. So whatever the way you want it, or else you can even do this one. Even this is acceptable. Okay, so again, the choice is yours. You can do however you want. Okay, and finally you have to do the reconstruction. So in reconstruction, you already know P, you already know K, and you have the 2D points from the projection. So what you need to do, you have to find P into K inverse into this 2D points. So if you have two 2D points, then you will have two vectors. So that will be, so let's say vec1 will be equal to P into inverse of K into 0.1, and the next one would be 2 into vec2. So these are the two vectors that you have, and the next thing that you can do is just you can find out the cross product of vec1 and vec2, which will give you the intersection. Okay, so right now it is showing error, but if you do it properly, I think you can get it. So now what you need to do is, let's call this vec3. Okay, so we have three different vectors. So what we can do is vec1, vec2, and vec3. So if we do this, let me call it B. So what is happening here is we have three different vectors and we have camera locations. So A is equal to camera locations. Okay, so I have A is equal to camera location and B is equal to three vectors. So what this is essentially a linear system. It's a system of three equations where you have to solve it using Ax equal to B. So you will be using this to solve it. Okay, so how do you solve for x here? X is equal to B divided by A. Okay, just remember it is not this divide. Okay, this is for regular division. This is for dividing through matrices. Okay, so this is how you find your 3D points. Sorry, 3D reconstructed points. So this will give you 3D reconstructed points for every joint. That is all what you have to do in this project. So the most important part of this project would be to maintain proper data structures, which will make your job very easy. So like I suggested, so you can have frame as one of your data structure, which will hold the frame number and all the joints information. Also, if you're working on, for example, 2D vector points and 2D vectors and points, even for this one, it is best to maintain all of them inside the frame itself. So you can go inside this function and update the 2D points into this frame structure itself. You can have another uh, field. So frame of one dot, let's call it point 2D. Point 2D is equal to some random number. For now, I'm just going to give 1, 2, 3, 4. Okay, then again you can have points 3D. After reconstruction, you again can have like this. Okay, so all of this will sit together. So for this frame, you know what are the joints, you know what are the 2D points, you know what are the 3D points. So this kind of maintaining data structures will help you a lot when you have too many frames. You cannot keep track of every variable when there are multiple frames, and you need those variables for each and every frame. So what I'm trying to tell you here is, so for each and every frame, you need to know whether it is good or not. So F is one of my fields. And then you have joints as one of the fields that every frame has. Then you need points 2D. Then you need point 3D, right? So you need to keep track of 4 variables for all the frames. And how many frames are there? I don't know, more than, I think, 214,000 or something. So you have these many frames and 4 variables for each of the frame. So you cannot keep track of them unless you maintain a proper data structure. That is why I'm suggesting you to go with this kind of data structure where you can know what is the frame number, joins, pointer. So it's very easy for you to access. For example, if I access f of 300 dot joins, I'll get, okay, sorry, frame. Oh. Frame of 2 dot join, sorry. Yeah, so I get this one. So if I do frame 2 of frame number, I get this. I get this one. Okay, so this is what I've been meaning to tell you. Okay, so maintain these kind of data structures. So this is a very big picture of project 2. So hope this will help you, and let us know if you have any doubts. Okay.